Okay, we are all set. Over to you, Ankit. The virtual stage is all yours.
Okay, thank you so much for the kind introduction. I'll quickly begin. And let me just share my screen. And I saw the poll that you guys are filling. Is glad to see that there are a lot of people from Asia, a lot of people from different locations, and looking forward to see what you're able to take away from this session. And let's just get started. So uh, this is how we're going to proceed. First, we are going to talk a little bit about uh, just a brief introduction about myself. Then I will quickly cover a little bit about NLP and more importantly, word representation within it. And then the practical application that we talked about. Again, the perspective that I want to give and, in terms of what I want everybody to take away from this is just the basics, the fundamentals. As everybody's aware, there are a lot of uh, new developments that have happened recently and over some time from advanced models like BERT to GPT to Chat GPT and so on and so forth. Um, we'll not be covering those in this session. However, the objective is to talk about how do we explore the data, what type of scenarios we might find, what do we do at the basic levels, because there might be certain use cases that you might have faced or you will face where uh, simpler solution might work better, or at least the simpler solutions give you the ability and the opportunity to examine how to proceed, why a certain thing is behaving in a particular way. With most advanced models, especially black box models, one concern that a lot of people in the industry have showcased or had is if somebody asks me why did this happen, it's a very difficult question to answer. So that being said, we are going to fundamentally just focus on the basics, the utmost level of that, and see how this session goes. At any point of time, like the moderator also said, uh, please feel free to raise your questions. I have put together some questions of my own so that we can make this more interactive. So please use the chat section, the Q&A section as much as possible, and we'll try to get this ball rolling there. Okay. So firstly, just a brief about me. Did my schooling in Sanskriti, then did my bachelor's in statistics honors. Post that operations research from Hindu College. Then I got into an internship, started working as a data analyst and into a full-time role, became a data scientist. And over there, my chief initiatives and what essentially I was working on with multiple clients in either the e-commerce domain or the retail domain or the digital marketing domains. And the type of tasks varied from using NLP for thinking of or coming up with the most optimal advertisements, creatives, and so on and so forth, lifetime attribution of your customers, to various other things from ranging from machine learning to NLP. And then post that, I joined another startup, Cygram Data Technologies, which we are focused on the reg tech space, finance and compliance aspects of it. And we are developing our own products and dealing with a lot of different challenges, especially when it comes to textual data, when it comes to NLP. So I'm really glad to talk about some of the basics here. But if anybody has any questions, please feel free to reach out. Always welcoming of any questions. Okay. Okay. So I noticed that a lot of the participants here are freshers, and therefore, based on my discussion with the analytics with their team, also it made sense to kind of give you a quick brief of NLP. I know a lot of you might already be aware of it because you've joined this session, or you might have some experience, but still, I'll just cover a little bit in terms of what is NLP, why does it matter, and the basic challenges associated with it. And through the way, I'll sprinkle some pieces of knowledge as to what my experiences have been when it comes to solving NLP related problems on the job or in the industry. Okay, so firstly, the simplest sense is we generate a lot of data. If you look at the internet, we have so much of textual data, most of it unstructured, but has a lot of valuable information. And daily, more and more data has been added. There are a lot of news articles that come up every day. There are a lot of websites that are coming up every day. And you, whether it's the web, whether it's emails, whether it's anything, it's essentially a medium of communication for us that has gotten imbibed into us, into the way we work so well that it is important to build systems that can either automate or understand or essentially make sense of language the way you and I do, but of course at a more scalable level. And I'm sure everybody has already come across a lot of different applications in their life when it comes to chatbots, Chat GPT making a lot of noise. We have Siri, Alexa, uh, Google Translation, whether Google or Ping, spam classification when you have mails that directly go into the spam folder, search engines. We write uh, queries in different ways, but a lot of times we get the most relevant results or the result that we have actually been looking for. And that's thanks to the ability of breaking down text um, and building a system or a model that is able to infer knowledge or understand what exactly you're looking for. So essentially, natural language processing, sits in between AI, computer science, and linguistics. Uh, there's this fundamental quote by Noam Chomsky, who said in one of his interviews that one of the greatest innovations is not what we're doing in computers, but most importantly, language. And the reason he said that is because before language, there was actually no way to communicate what exactly you're thinking, what are your thoughts. And we built language, we built the words and alphabet and so much information and knowledge into these structures that language is now as fluent as anything else. We just use it without even thinking a lot of times. But the point that I bring out here is that it is governed by certain rules, right? Secondly, each word or set of words has some relationships in them, uh, which allows you to infer knowledge. So that is why your natural language processing is an important aspect, because there's a lot of utility, there's a lot of data, uh, a lot of complications as well, which I'll cover in a couple of minutes. But that is why NLP is important. Okay, I would not go into the detail of all these particular tasks that you see in front of the screen, but essentially NLP has come a long way since the start of it. There are a lot of different tasks like relation extraction, uh, NER, named entity recognition, that is, automatic summarization. Some of these things, we might already be aware of that these things happen or these things are being used. And then there are more complicated challenges also, like question answering. There are a lot of models that have recently come out in the last few years, becoming very prevalent in the industry to see. Apart from that, there's co-reference resolution, which is resolving pronouns, or in other words, figuring out if there's a he did this, who is this he that we speak of? Who's the pronoun that, who's the entity or the organization or individual that I'm supposed to substitute against that pronoun? Because what essentially we have figured out or we've struggled with initially was that if you give me large pieces of text or paragraphs or documents where maybe in one sentence we have ABC Limited referred to as the company, Now, everywhere else, the company is being talked about. How do I figure out that this is this entity? And while some of these things, because we use this on a daily basis, start to sound easier, uh, there are a lot of complications when you have to put it in machine terms or when you have to build models around it. Okay. Okay. So I'll give you an example of one of the complications. So this is one of the headlines that I put together, but it quite demonstrates one of the complications. So juvenile court to try shooting defendant. Now, we as humans know that we have some common sense, some contextual knowledge associated with any kind of statement, and therefore we are able to figure out what might be, said in these type of statements. However, teaching that to a machine is a much more complicated measure. Of course, there are different algorithms available. Like even if you look at neural networks, right? It's still a lot of dimensions, a lot of different neurons that are speaking to each other mathematically to make sense of language, to understand language patterns. So ultimately, there are a lot of complications of how we write text or how we get text. Uh, Even in news articles, headline is one example. There could be a lot different complications that might exist. Like in an article, let's say if you have a sentence with multiple entities, and the following sentence goes on with he, uh, it might be easier for me or you to just read the sentence and say, okay, he refers to this person, but it might not be as easy for the model or the system to figure out unless sufficient amount of training data or effort has been put into it, that it is able to solve those type of complications. But dealing with natural language is a complicated task. You usually don't get uh, you know simple, easy to use data sets. There are a lot of structural ways that text could be written or should be written, but you won't find it a lot of times. And it becomes definitely a challenge from a data understanding, a data evaluation perspective also, because ultimately, uh, if you think about it, whatever you feed into your model is the outcome that you're going to get. So if you, feed bad data to the model will learn those patterns and probably will result in bad predictions. So it is important to be aware of what kind of inputs, what kind of data you have. Okay. So somebody has just posed a question, and since it's relevant, I'll just pick it up right now. What are the specific challenges, this is posed by Lalit, we can face regarding the data in NLP? So very good question. First is you, like if you think about it, if you have Twitter, and let's say the objective is simple, you want to extract hashtags and look at the sentiment of those tweets. Okay, why would somebody be interested in this type of an activity? If let's say you're an investor in Adani Enterprises, based on tweets, based on the momentum of the market, you want to figure out how you want to react, because ultimately, or how people are going to react, what's the sentiment against that particular entity. uh, so you go to Twitter, you fetch all the tweets that you can. Now the problem is everybody has a different way of writing, right? So it might not be as structured as a simple sentence. Second, there will be a lot of emojis, emoticons. You might have some words in your library, but there will also be certain uh, languages, certain cases or words that you're not well versed with, you're not aware of, because they're something new. They're not in the dictionary. They're just some things that people made up as words, but are now common. So you'll have to deal with those type of scenarios also. Second is sometimes what happens is when you pick up a data set, you might realize that the patterns or the structure of the data set And I'll get a little more technical here, unfortunately, but it will give you some idea. So, if let's say I'm saying I have done an activity, like I have gone for swimming, I have gone for driving. So you see that there is a pattern, right? Or a structure of the way language is being used. So if you don't have enough diversity in your data, depends on the use case that you're training your model for or trying to solve. But a lot of times, and this is true with machine learning also, a lot of times what happens is your production data, your live data, your client data is following a different distribution as opposed to uh, what is exactly the data set that you have trained on. And same is true with natural language processing, textual data as well. You might have certain patterns that are very prevalent in your training data, but you might not find them in your prediction data or your actual client data. We'll talk about exploration in a couple of minutes. So it will give you some ideas of how to go about it, and I'll address more and more questions along the way. Okay, so I'm going to do a quick brief refresher of word representation and the history of NLP, at least when you think about it. So uh, you don't need to essentially go through, hundreds of articles about NLP. Just try to think about, at least in this section, logically, right? So we know we can understand text, but we also know computers cannot understand text because they don't know the meanings of things. They don't know or understand what does word mean, text mean, represent mean, these type of words, unless specifically provided some training data, it will not be able to understand on its own, right? Or building some features and so on and so forth. So that is essentially. Now, if I have to explain my text, my message, my SMS, or my paragraphs or emails to my machine, how can I do it? And if you think about it, all our computers deal with numbers, whether it's binary or hexadecimal or some or the other format. We are essentially converting everything into numbers. And that is where the concept of word representation comes into picture. Yes. Thank you, Lalit. I really appreciate all the inputs that you're giving, Hex, Octal, appreciate all. And please, everybody else can also feel free to chip in with your chat, your comments, your ideas. It will be really beneficial. So coming back to it, that's where the concept of word representation comes. But now let's think about it. If I was, let's say I don't know much about NLP, right? If I was to really build a way to transform my text into numbers, or how would I actually go about it? So one way is, hey, why don't we just come up with a dictionary or what I call a taxonomy over here? I'll talk about it. But basically a long repository of words, and maybe give like a score or a weightage or some value or number associated with it, right? The other way that I can logically think about it is simple. Just where a word exists, I put a 1, else I put a 0. So we'll talk about these in more detail. But my point being right now is that you can logically think about these things, because you will also come up with some ideas that are synonymous with the algorithms that are in use. So that is a good idea to think about. Okay. Why is word representation important? So this is a very good saying, you shall know a word by the company it keeps. And if you think about it, when you do fill in the blanks in school, right, based on whatever is written, whatever the words are, you're able to fill the blank based on your understanding of what is happening, what the context is. Yes, exactly, what the context is. And that's very, very important when it comes to natural language. Okay. So I've kind of covered why do we need to do any processing? Why can't computer just understand things? Because it is primarily built for numbers. That's how it has been operating. Now I talked about building a dictionary, building a taxonomy. It's a great idea, especially when you have a limited use case. So for example, let's say that I'm looking at a large corpus of Quora, and for everybody, Quora is basically where you pose questions and you get answers from the community. But a lot of times people could be insincere in the way they answer those questions, right? Now, if I think about it, what is one easy way or one kind of feature that I can build? If somebody is using abusive language in their answers, probably they are being insincere. They're not responding to the question properly, and I want to flag it off, right? So in taxonomies and dictionaries, it's not just a word list. It has some thought behind it. Plus, so I have covered two things over here, like hypernyms, which is a broad category. For example, dog is a hypernym because it covers Coolie, Chihuahua, and any other kind of dog breeds that you can think of. The other is if you have a set of synonyms, because a word might not necessarily be used in the same way, but it means to use essentially, sorry. So a word might be written in different ways. Like you could have, fraud, scam, etc. All of them mean the same thing to us as a user, and it is important to consider these synonyms as well. So, for example, and this is taken from NLTK WordNet, relatively easy, but you could have canines, you could have domestic animal, carnivore animal. So what you realize over here right now is that this is like a hierarchical structure, that dog is not just a canine, but canine, it gets covered the domestic animal, and animal is like a superset which covers domestic animal. So, however, and when NLTK was built, a lot of it was built based on either rules or structures that people actually sat down and built. That language is written in this form where a noun is followed by this in most cases, or a long repository of words and their meanings has been tagged. And this is how NLTK initially was built. Very popular library, even used till late. But when you talk about dictionaries, when you talk about taxonomies, there are a lot of issues or limitations associated with it. One is you miss nuances, like an expert in NLP versus being good in NLP. Good and expert, we know that there's a subsequent difference between the two. It implies different skill levels, but it's difficult to build a dictionary or a taxonomy or word list that understands that. So when I give you the example of, classifying whether an answer in Quora is insincere or not, if you are taking a long repository of abusive words, there would be words that you've missed out. And there would be new words that you've never seen, but would come up. And that is where things become interesting, because you have not covered those words, but they are important for your use case. It becomes a very manual task, requires a lot of human labor to curate, to review, and compromise accuracy, because like I said, it's not capturing the context of words like fraud and scam, meaning the same thing, right? And so on and so forth. I know people are posing questions. What I want to do is I want to quickly get through a few slides, and then I'll come back to these questions, because that will make it easier and we'll be able to cover most of the things during the stipulated time. So apologies for not taking the questions on the go, but please feel free to keep putting together your questions. Okay. Binary vectorization. Okay. So, like I said, if you have a text, right? Like, if I was to say, hey, let's just put the presence or absence as indicators, as binary indicators, ones or zeros, um, you can essentially represent it as a vector or a set of numbers in a matrix. So, uh, a good way to think of it is the way, if you guys have used pandas and a little bit of machine learning, there's whenever you have a categorical variable, you use usually pd dot get dummies, which creates binary columns of ones and zeros. So similarly, over here, we are doing practically the same thing, but in the vector form. So essentially, that is what we're doing with binary weightages. However, one thing that is of note, one thing that is important here, is the fact that when you look at these vectors, so I've given an example, 0, 0, 1, 0, wherever size occurs, we just put a 1, and wherever capacity occurs, we put a 1, and the rest of them are 0. Now, unfortunately, when you look at word similarity, you're saying, hey, are these vectors similar to each other or not? And if I was to do a multiplication, which is what we call orthogonal, what happens is you end up with a vector that's 0. It's a very limited example, but it essentially will give you some inclination or idea towards what are the issues with binary vectorization. And again, it's very logical. So when you think about it, right, when you're creating these vectors, if you have very common words, they will get fired up insanely. Like a word like as, to, the will get a lot of ones. And that is why text cleaning or handling the noise becomes very important, because otherwise your model will get, a little biased or might learn the wrong kind of patterns. So when it comes to binary vectorization, important steps are text cleaning. Example could be making it lowercase, stemming or lemmatization. I'll cover in brief what these things are. So stemming or stemming or lemmatization essentially is we are trying to identify the root word. So when it comes to, for example, swimming, swimmer, swam, uh, the underlying thing that you're trying to say is same, swim. Now, the reason I said swimming, swim is the same, right? Or swam is the same, while the tense is different. Um, when it comes to your binary vectors, you don't want separate columns, or you don't want separate occurrences for these to be captured. You want to normalize or standardize them to essentially give you just swim. And that is where your things like stemming, lemmatization, these type of techniques come in. Secondly, stop words. So as, the, these are very common words that in any and almost every sentence, you'll find some or the other stop word, which is what we call. And it is a good practice to remove these things, especially when you're talking about binary vectorization, count vectorization, and other things. Okay. And one concept that is here is, so what I mentioned in the saying a few minutes back was that it is important to capture the context, right? And if I was to say, hey, this burger is good, good as a keyword being put in a binary vectorizer is good, is great. It will help, right? But if somebody had said, this burger is not good, uh, good alone does not give me the context that I'm looking for, right? And therefore, not good probably makes more sense. So the way we can break up a sentence or a piece of text can be either unigram, which is single words, or bigram, which is two words, or in generalized sense, n-grams. So, Mohammed, hopefully that answers your question. N-gram, bigram, trigram. If we do it at a word level, we are just saying split up the sentence at a single word level, or split up the sentence at multi-word level, another way to so on and so forth. Or another way to look at it is at a character level also. So essentially, instead of breaking things at a word level, you can do the same thing at a character level. Like for another, it would be ANOTH. So every character is a separate token for us, or a separate element for us. Okay. Now, one thing that is of note here is when you talk about binary vectorization, you miss out on something, which is if I had, let's say, a sentiment or a review done by a customer, and they had used the word good twice, or in the small message that they sent, they have used great 5 times. Now, when I'm trying to figure out whether the review that somebody is given is positive or negative, that is the sentiment of it, this type of information that the word great has been used 5 times is more influential than me just saying, hey, great has been used. It will allow me to distinguish between highly positive sentences or reviews versus average or mediumly positive sentences. So what is getting missed out over here? We are missing out on the frequency. So from binary vectorization, the next logical step that comes in is count vectorization, where if you think about it, we're just saying, hey, if a certain word has been occurring multiple times, instead of just putting a 1, put a number, put the count associated with it. Okay. Now, all of you will see that purposefully I've not put in the limitations. And what I want, hopefully, all of you to do is, if you can just in the chat, think about the limitations logically. You don't have to Google it. You don't have to. Just think about, okay, if we are representing the text in this particular way, what are the things that I'm still missing out on? There are certain things that I have already covered in binary vectorization, and those things are also here being followed. I'll give a brief second so that you can look at the limitations. Some of these do exist in count vectorizers also. If you want, I can show you taxonomy and dictionary related limitations as well. But just think about it, and within a couple of minutes, I'll go through the comments and call out, or we can cover the issues associated with count vectorization as well. But hopefully you guys understand what is count vectorization. And I just quickly looked at it. And yes, we are definitely missing the context of things. But I'll let others also try to think of different issues that might be associated with count vectorization. Okay. Now, one thing is, like there might be certain words that are rare in occurrence in our documents, but very important. And that is where term frequency, inverse document frequency comes. It's a scoring mechanism where it will try to upvote or essentially give better scores to words that are rare in nature. So this is what you see over here as a fundamentally very simplistic example, but it will at least give you an idea of what is happening. So term frequency is, you can think of it just like we were doing in count vectorizers, just how many times the term T, or basically the word that you're looking for, occurs in a document upon the total number of terms in the document. So, if I take the same example as count vectorizer, timely product delivery, product was good, is document 1, and product was damaged is document 2. So now, if you think about it, product is not going to be a stop word for us. It's very specific to this data set, but it is occurring multiple times, and I don't want to give it very high weightages. So therefore, my requirement is that these type of words get downvoted. And that is where TF-IDF essentially comes in. So TF, like I said, just simple math where you're just looking at the terms, occurrences upon total terms in the document. So in C1, we had 6 words. I have not removed stoppers or anything, not done any cleanup, which usually would have been some steps that I would have followed. But for explanation purposes, put it relatively simple. So we have 6 words, we have 3 words, and product, which has been mentioned twice. So 2 by 6. In the other document, C2, customer review 2, we have 1 by 3. So we have 0.33 coming in both. Damaged also, we have calculated the numbers. Now we come to IDF. Okay. So for a second, just forget the log. It's basically saying number of documents upon number of documents with term T. So if, let's say, I have 2 documents, and in both of those documents, the word product exists, I've done 2 by 2, right? Which is log of 1. Now, where does this log come in? Okay. So the more closer the value is to 1 over here, and you take a log of that, your resultant will be closer to 0, or in this case, it's actually 0. So ultimately what we have done, if you think about it, by bringing things to a log scale, we have essentially penalized those words that frequently occur, right? Damaged, however, still gets a value, and TF-IDF is nothing but the product of your TF score, your IDF score. So if you can see, we have just done 0.33 into 0, and so on and so forth. Okay. What are the limitations? Now I will address, so I will just quickly go through only the specific parts where somebody has talked about. So yes, context in count vectorizer is getting missed. Second aspect is, second aspect is sparsity. So what happens is, when you have a large corpus of, let's say, millions and millions of documents or millions of words, what might happen is, when you build this vector, firstly, it will be very large. Secondly, there will be a lot of words which are holding just 0 values. The mathematical term, when you have such scenarios where you have missing values or no values for a large section of your matrix or vector, is what we call sparsity. So the problem with sparsity is, when you do vector multiplication, it becomes slightly difficult. We are not saving additional information in a lot of these columns, but they are contributing to your compute in terms of resources you're taking, in terms of time you're taking. So there are some implications of count vectorizers, or even binary vectorization, where if you have a large corpus, this is one possibility of happening. Okay. Secondly, same thing when I talk about TF-IDF, and keep in mind, when we're talking about binary vectorization, we talked about noise. Count vectorization, yes, noise is also a factor. That's why removing stop words, cleanup of a lot of things is necessary. But again, going to, let's say, let's take an example. Let's take, again, insincere classification of insincere or sincere answers on Quora, right? If somebody has mentioned an entity name, the name of an individual or organization, that is not of interest. That might not be interesting for my model to learn because that organization or individual's name is specific or localized to that particular question and therefore might not translate well, right? So in TF-IDF, or rather in any of these vectorization techniques, if we do not do cleaning properly, what might happen is you might give, and again, entity names can be very rare. Like if there's a question about, let's say, analytics Vidya or Ankit Gadi, you might not find a lot of questions that are specifically talking about this entity. But because it is rare, because there are not too many questions, you might give higher scores to these particular words or pieces of text. And that might result in the wrong information being learned by a model. So very important. TF-IDF is good. A lot of times we end up also using it for just exploring the data. What are the frequencies? What are the type of words that are important? I also talked about, for example, building taxonomies or dictionaries if your use case requires it. So you can actually use TF-IDF to quickly explore your data, to quickly understand what are the common words, what are the rare words. You can build word clouds, and that will allow you to quickly understand how to build that dictionary if needed, how to build those word lists if needed. So that is essentially what TF-IDF is. Okay. Okay. So I think some of the questions are also being answered along the way by others, which is a great thing to see. Thank you everyone for being so participative in this. And yes, so the last question, the most recent one. Okay, TF-IDF also creates a matrix of large size. That's correct. How do we deal with that? When you use different libraries, like for example, GenSim, they have allowed you to put some hyperparameters or parameters which allow certain amount of fine tuning in that. So for example, you can say minimum frequency of the words has to meet a certain criteria. Like maybe 5 times. It has to occur at a minimum 5 times for it to be considered as a part of your corpus or word list. So you can curtail those type of things as well. If we have a spelling mistake or short forms, right now, if we don't do cleanup properly, you will end up with those issues. There are a lot of different libraries that fix spelling mistakes. Of course, they can't fix spelling mistakes in names, but at least in words, that can be done. Secondly, short forms. So if it can depend, if you have certain elements to it, like let's say you have a corpus of or a dictionary of abbreviations for company names. You can essentially do those fixes on the go. You can also remove if, let's say, a character length is lesser than a particular number, like let's say 4, because you usually found, at least in your data set, that those were common words or those were abbreviations. So highly dependent on the use case that you're dealing with. But these type of things can be taken care of. Depends on what kind of scenario you're tackling. With Twitter data, you'll probably do something completely different as opposed to what you're doing with, let's say, news article data or some other data set. Yes. So TF-IDF is a technique and GenSim is the library. So GenSim They have optimized a lot of different algorithms, and they give you the frameworks to apply these algorithms. Feel free to explore. It's actually a quite good library that is often used, especially for things like topic modeling, TF-IDF, and so on and so forth. Okay, since we are, running out of time, what I'll do is I'll quickly go over a few things, and over time, I think it will cover a lot of these aspects. So last element that I want to talk about before I start talking about the problem that I want to give you guys is embeddings. So, we talked about vectorization. Basically, we are converting text into numbers in some shape or form. There are a lot of different techniques. What I've done is I've just covered a brief introduction about things. Yes. Okay. Sandeep, if you have a question, I'll just allow you to talk and you can take it up.
So you can put the question in the chat.
Sure. That will also work. Okay. So embeddings. Now there are different ways, and I would not cover things like word to vec and so on and so forth in this session because it demands or deserves its own session. In all fairness, but what essentially you're trying to do is you're trying to, instead of thinking of just ones, zeros, or frequencies, or some score that TF-IDF has determined, right? What you're trying to do is you're trying to capture the context. And why is that important? So, the word row. Now, based on the company of the words, what in terms of what we call context window or surrounding words of a particular word like row, you will be able to figure out whether you're talking about the rows of a data frame or the activity of rowing a boat. And what essentially I'm bringing up to is that there is an important element of probability of co-occurrence of words. Certain words occur together or are more often likely to occur together. And what you want to essentially capture is those probabilities. So one way of actually thinking about embeddings is also creating co-occurrence matrices. Like if this word occurs, how likely is that it will be followed by a word B? Second aspect of embeddings that you try to capture is similarities or semantic relationships between words, right? Dog, cat, these are animals, usually have or are used in a similar context. There are a lot of different things like word to vec, dog to vec, and so on and so forth. But basically, just like vectorization techniques, embeddings can be used as input to your models because now they will understand the context of word much better because you have essentially figured out a way to decode a word into a large set of numbers. So, you'll come across, for example, glove embeddings or uh, uh, wiki embeddings, which essentially what they've done is they have, in the simplest sense, created a fill in the blanks model where they took a large corpus of text, millions and millions of documents from the websites, news articles, and so on and so forth. And they tried to figure out, okay, if I delete this word, based on the surrounding words of, let's say, two or maybe more, can I figure out what is supposed to come here? And instead of converting it into a single value, a single probability, what they have done is they have created a vector of maybe 100 dimensions, 300 dimensions, and so on and so forth. Again, the objective here to just introduce what embeddings are and the importance of them, because if you think of it, even your bigger models like BERT and so on and so forth are building embeddings for your words, are building embeddings, right? Okay. So that is where embeddings become important. Okay. So, okay, I'll cover the text classification problem statement. I've already covered a few elements while I was explaining these different techniques. And then I'll cover a few aspects of it so that you can get started. Uh, Objective is I'm going to share these slides and make sure that you guys get these slides. Second, there are certain links that I've shortlisted from my own repository, which you guys can also use, including pieces of code that you can use to try these problems out. But essentially, you learn best when you do. And that is why I want to leave that problem statement with some ideas of what can be done so that you get an idea of how to apply these techniques as well. So, as I mentioned a little bit briefly, right, Quora has sometimes a lot of toxic content. The way people have answered might not be what you're looking for. And uh, when I was saying somebody has put it in false pretenses, put it or answered a particular query, user query in a way that is just not right. So, uh, in short, it's either a non-neutral tone directed at someone, it's discriminatory, it's contains false information, and so on and so forth. So this is where this problem statement comes in. Very interesting, right? One important element that I would leave you with, and maybe in future sessions we can cover more aspects of it. There is an entire blog which I've written, which covers all the elements that I've spoken about, along with some additional things, which unfortunately, based on the time, it was difficult to cover. And therefore, we stuck with the basics first. Uh, but basically, in short, how do you cover this? So let me just quickly show you. So there is an element of data exploration. How can we do data exploration? So first, of course, look at the train, look at the test shape. These are, we just have the IDs, we have the question text, we have target, whether it's sincere, insincere. You can do simple plotting of the target. Is it a balanced class distribution or unbalanced? Because that will also determine the type of decisions that you take. You can look at box plots of different aspects. So word counts, because sometimes what happens is you can not just build features using uh, ideas like, hey, let's just take a long repository of abusive words list and plug it into the system. If it exists, if the frequency is more, there is something wrong there. We should flag it off as insincere. You can have ideas like that. You could use patterns. So again, giving you ideas right now, but let's say if a particular abusive word is used and a negation is not used in front of it, maybe you want to react differently. Maybe you want the model to learn that pattern in a different way because there's some logical cadence to it. Similarly, you could have POS tag related patterns, or so for example, if a noun followed by a verb where the verb is, let's say, committed, you want the system, or usually it results in insincere, outcomes. So these are all different ideas that you can explore and see with this data set what makes sense. But if you have to explore your data from, and again, even with word counts, you could have a realization, hey, in whenever somebody is writing insincere, they put in a lot of words, they put in a lot of information. Maybe there is some correlation there. Again, correlation does not mean causation, but these are ideas that you can explore using word counts, using unique word count distributions, character counts, punctuations. One simple thought process is, hey, I would have a lot of punctuations, uh, right? And therefore, so for everyone, I'm sharing these particular slides. I'll figure out from analytics with their team how to share them. But I have my website, my company, Zygram's website, and my LinkedIn profile also. So I will share all these details with you guys, and you don't have to worry about it. But coming back to this, so you can look at punctuations, you can look at uppercase count distribution. If somebody's writing an abusive word in uppercase all the time, you'll get certain elements out of it, right? You can look at word clouds, like I said, to build repositories. Again, this is without any cleanup, but it gives you a lot of idea that, hey, cleanup is needed. Text pre-processing. So I covered a few things. I remember somebody had asked a question regarding, I think, swimming, somewhere in the chat. I was just seeing that. Okay. I am not able to find it again, but I think this should give you some inclination of why we use stemming, why we use uh, lemmatization. Basically, we are trying to reduce the combinations or occurrences. Yes. Lalit, if you could just put it in the Q&A section, it would be easier to answer because it's getting lost in the chat. But you can convert to lowercase, you can remove punctuations, numbers, stop words, lemmatize them, so on and so forth. There's examples of code here. The entire code of data exploration, text classification is also available over here. Using deep learning, how you can do it, introductory stuff. There's a blog as well as the code available in the links that I'm going to share. I'll just share this on the chat for everyone to see. Perfect. So feature engineering, I talked about some ideas, but let's say sentiment. You can apply a sentiment model. You can check if the sentiment is positive, negative, and use that as a feature. Now, once you create all these features using whether sentiment, whether dictionary patterns that you have observed in your data set, what essentially you can do is, or you can even use embeddings. So what is one of the simplest ways to take embeddings? Not the most accurate way or the best way out there, but one simple way, if you don't want to get into the hassles of deep learning right now, is if you have a text, like for example, this part is what makes the difference, just this piece of text. In the embeddings that I've mentioned in this list over here, um, Google News embeddings, Glove embeddings, for each and every word, there would be a vector associated with it. One way to look at it is for this sentence, such as this part is what makes the difference. Each word will have a vector. And what we can do is we can just aggregate the vector. We can just average it out. Again, if there is a lot of noise, if you're using a lot of different, stop words and so on and so forth, which have not been removed, there will be consequences to it. But it's just an idea for you guys to explore. But using pre-trained embeddings can be done even with machine learning. Of course, better advice to fine tune it using word2vec and other different models that are there, which use embeddings in a much better way. But in the simplest sense, you can use that also. Okay. But once you've built these features, what you can actually do is you can go the machine learning way, which is apply regression on it. You can apply random forest on it. What that will allow you is to pick these features and just train a model. Okay. In the code that I've shared with you guys, at least on the link, text classification, you'll not only find the data being used, how it is being used, what is the pre-processing, again, explained step by step. But for example, LDA using GenSim, which we've not covered, but it's called topic modeling. It's also a good way to explore your data. And what we have done is essentially we've created these features and created models on top. And these models, and then finally created accuracy. So my suggestion and advice to everybody is don't look at it, don't look at the code at the start. First, go through this particular article, come up with your own ideas of what features you can think of, and then start doing it. And when you get stuck, that is when you should, I think, refer the code. That will essentially allow you to have independent thought and try to think of ways to solve this problem. Okay. That's it from my end. What I'll do is I'll just quickly take up questions now.
So before we proceed to answer your questions, I would like the attendees to please fill in the feedback poll, as it helps us to conduct more sessions.
Perfect. So while you guys fill the poll, I'll just quickly go into the questions. And again, thank you so much for everybody who's been attending. And thank you so much for all the chats. I've seen a lot of active participation, which is great. So one of the questions is, how do we reduce size of TF-IDF vectorizer? So I believe this was mentioned in the chat and answered there as well, but I'll just cover it. We basically have certain parameters like the minimum frequency, like how many times a word has to sufficiently occur or at least occur for you to go ahead with this particular process of building the vector space, building the TF-IDF model. So it will ignore infrequent words, or it will ignore completely infrequent tokens. Okay. Okay. Now coming to the next question, bigrams, trigrams, n-grams, and give some context around these. What are they? Why do we use them, and so on and so forth. So think about it. We have all these words, but if I consider these words at a singular level, right? So by that I mean we are essentially using a unigram or a single gram. Now, we are breaking up my entire corpus or piece of text into small tokens, which we call tokens, but you can consider them for now words in the simplest sense. Now, if I was to consider two words together, almost like we are now moving towards phrases. So two words together, three words together, four words together. So bigrams essentially means we are considering two words together. Trigrams means three, and so on and so forth. So n-grams. Now, keep in mind, imagine like you have a very big corpus, like for example, Quoras itself is quite big. The problem statement that I shared, you have, as you increase the size of your n, means if I say, hey, let's just do 10 grams of words, the frequency of their occurrences will reduce. So you have to keep that in mind. But essentially what you're trying to say is, if these two words are occurring together, there should be a score given to them together rather than just a single word. So, like not good, like my burger is not good. Not good is something that is important to me, together rather than giving separate scores or weightages to not and separate scores and weightages to good. So that is essentially bigrams, trigrams, n-grams. I've explained it at a word level, but you can do the same thing at a character level also. And there are different use cases where words versus characters make sense. Okay. Yes. So which technique GPT is using? Is it having a large corpus with it? So firstly, GPT has been trained on a very, very large textual corpus, lot of data. Secondly, it's a completely different ballgame. So I think somebody has also mentioned transformers here and masked language model basics. Uh, it is very interesting topic. I would suggest definitely read it up someday. But you know, take it at steps. Just go with the basics, then progress towards transformers. First, you'll go for BERT and so on and so forth. So go stage by stage, because it is a completely different deep learning model which is based on attention, and especially when we talk about BERT and other things. But I don't want to cover this right now because it's a very long answer to this question. But yes, it is able to, in short, it is able to capture the context. It is a transformer based model. It has been trained on a large corpus.
I'm sorry to interrupt, Ankit, but we are going below after the time limits. If we can
Sure,
wrap this up. Okay,
sure.
thank you.
So I'll just cover these two questions quickly.
Yeah, yeah.
Um, sure. So firstly, in terms of internship, we at SciGram open internships. I think we've already closed the current set of internships that we have. But in future, if anybody wants to, please feel free to apply. And if you're a fresher or experienced, if you have any job openings, please feel free to apply. You can visit the website. I'll share the link. Okay. Uh, what deep learning techniques are important when it comes to NLP? So quickly, right now, the name of the game is transformers, but I would suggest go with the basics, slowly develop, because the intricacies and the depth required when we talk about deep learning techniques, especially if you're either trying to build one from scratch or even when you're reusing a pre-trained model, you need to know how they work. You need to know the nuances because you might be asked those questions in the future. So, uh, in short, transformers is the name of the game right now. Earlier, it used to be RNN and LSTMs also used to be used for NLP, but not that much anymore. Mostly it's transformers now. But you have other types of embeddings and associated models like fast text, which is used. You have Elmo, which is another set. So you can think of that. Uh, so this is somebody who's anonymously put in question, which is, uh, can be right for you. So for my blog, Data Science Discovery, if you're interested, just reach out. We'll see if there's something that can be done. Okay. Thank you so much, everyone. It was great to have this session. Thanks to Analytics Vidya team for organizing this session. It was really helpful.
Thanks a lot, Ankit. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Thank you. And I'll share this particular this PPT with and the links again with the moderator. And I'm not sure how it will get across to the people, but please feel free.
Okay. I hope you guys have filled the feedback poll. If not, I request you to please fill in the feedback poll as it helps us to conduct more such sessions. We'll be back with another session of Data Hour on the 1st of March, and the link is in the chat section. Till then, bye bye and keep learning. Thank you.
Thank you.